Hi, today we're going to solve systems of equations by substitution. And we're just gonna start. So I wrote out the steps here, although they're kind of confusing when they're written out that way. So hopefully you can kind of watch them as I go through it. So systems of equations, again, are two or more equations that are graphed on the same coordinate plane. So for systems of equations by substitution, you want to choose one of the equations to solve for x or y. Sometimes that's super easy to decide which one, and sometimes it's not. And this one actually is a case that people find very difficult because they are both solved for one variable. So in this case, they're both solved for y. Step 2, substitute into the other equation for that variable. So you can see here we have y equals 4x minus 1. Okay, and here we have a y also. So what you're going to do is substitute this 4x minus 1 into the other equation where you see y, because y equals both of them. So we're going to have 4x minus 1 equals 2x minus 5. You can see that we substituted for y. Again, this case I find the most confusing myself. Now our equation is in only one variable, so we can solve this following the rules of solving equations. When you are solving equations, you say, can I distribute? No. Can I distribute? No. Can I combine like terms? Nope. Can I combine like terms? No. Add or subtract something. You have a choice. I'm going to subtract 2x from both sides. 4x minus 2x is 2x minus 1 equals negative 5. All right, add or subtract something else to get the variable part alone. I'm going to add 1 to both sides. That way, our term that has the variable is already by itself. And lastly, divide. So we're going to divide both sides by 2. X equals negative 2. All right, so awesome. Now we know what x equals. We are going to substitute this value for x into one of the original equations for y, or for x. All right, so we have x equals negative 2, and one of the original equations was y equals 4x minus 1. So you can see we can substitute negative 2 for x. So y equals 4 times negative 2 minus 1. 4 times negative 2 is negative 8 minus 1, which is negative 9. And then lastly, write the solution as x comma y. So negative 2 comma negative 9. All right. And just in case you were like, oh man, I'm not sure if I got that right, you can check this in Desmos. Let me turn my brightness down a little bit. Okay, you can check in Desmos by typing in both equations, y equals 4x minus 1 and y equals 2x minus 5. And now, I don't see the intersection, but I can move down. And if I touch it, it tells me that they intersect at negative 2, negative 9. And that's what we got. So that's awesome. All right. 2 more examples. Now I'm going to set this up more like how I do it on my own because I have kind of a setup that I like to use. I like to write both equations side by side. And I'll show you why I like this notation better. All right, so we need to solve one of the equations for x or y. This equation is already solved for y. And so we actually don't have to do step 1 because it's been done for us. So now, everywhere I see y in this equation, I'm going to put 6x. So 2x plus 3 times 6x equals negative 20. You see how y equals 6x. So where I have a y, I can write 6x. All right, now we're going to solve this equation. following the rules of solving an equation. Can I distribute? No, but kind of. I can multiply right here. So 2x plus 18x equals negative 20. Can I distribute? No. Can I combine like terms? Yes. 2x plus 18x is 20x. Can I combine like terms? No, nothing to combine with. All right. Now we have 20 times x, so we need to divide both sides by 20 to get the x alone. X equals negative 1. All right, so now we know our x coordinate. We're going to find our y. So we're going to go back to our other equation, which was y equals 6x. And everywhere that we see an x, we are going to put negative 1. That's why it's called substitution. And simplify. 6 times negative 1 is negative 6. And now we have what y is. So the answer, negative 1, negative 6. All right. And again, you can check your answer in Desmos by graphing y equals 6x and 2x plus 3y equals negative 20. There's the intersection. That's where we find the answer. It tells us the answer is negative 1, negative 6, and that's what we got. So we did it right. All right, one more example. Again, I prefer to write mine side by side. All right, and I chose this problem because this one has another step. Step 1, solve one of the equations for x or y. So you really want to take a look at both equations. Which would be easiest? Well, this one, x and y both have a coefficient, so that might be more difficult. This one, y has a coefficient, but x doesn't, so it would be very simple to solve this for x. So that's what we're going to do. We're going to move that 5y by subtracting it from both sides. So x equals, these are not like terms. We cannot combine them. So 4 minus 5y. All right, now we have x alone. So we're going to rewrite this one. 3x plus 15y equals negative 1. And anywhere that we see x, we can substitute 4 minus 5y. So 3 times 4 minus 5y plus 15y equals negative 1. Can I distribute? Yes. So we need to do that. 12 minus 15y plus 15y equals negative 1. All right. Can I combine like terms? Yes. 12 and negative 15y plus 15y is 0. So that goes away. Okay, so now this is weird because we have no variable and 12 equals negative 1 doesn't make any sense. When you see something like this, it means it has no solutions. All right, and remember, no solutions means that these are parallel lines. So let's take a look in Desmos so you can see how that really looks. X plus 5y equals 4. Okay, you can kind of see it up there. Second equation, 3x plus 15y equals negative 1. Do you see how those are parallel lines? That's why this comes out that way. It's so weird, but that's why. Okay, and that means there are no solutions to this system of equations. All right, I hope that helped. Have a fabulous day.